everyone. Thank you for joining us on AWS Summit ASEAN, and welcome to this session. This session is going to be really exciting as we're going to discuss about how we can build microservices with Amazon ECS and AWS Fargate by using developer tools, and they are AWS Copilot and AWS CDK. This is an L300 session designed for those of you who already have been working with AWS and looking for a solution to improve your system with AWS technologies. My name is Doni Prakoso. I'm a developer advocate covering for ASEAN, and let's start this session. In this session, we have lots of things for you, and here's the key takeaways after you attending the session. We're going to walk through few practical demos on solution of challenges to build microservices using development tools such as AWS Copilot and AWS CDK. From deploying services, implementing release pipeline with CI/CD for multiple application environments, integrating asynchronous communication with PubSub pattern, and how to add additional resources by integrating with AWS CDK. And at the end of the session, you will know how to use AWS Copilot and AWS CDK to properly build microservices. Before we go to the technical how-to, let's set the context on why developers are adopting modern application development. Companies are looking to become more agile so they can innovate and respond to change faster and innovate more rapidly. And this requires a different kind of application than what was common years ago. Organizations need to modernize the way they build and operate applications. Modern applications are built with a combination of modular architecture patterns, serverless operational models, and agile developer processes. And that new business necessity led us to journey to microservices architecture. With microservices architecture, we can achieve higher development velocity with flexible scaling and resiliency, and help us to meet the growth and demand at scale. But building microservices also present challenges, and we need to rethink on how we can build a proper system. Which container orchestrators I need to use? How to maintain multiple environments parity? How about CI/CD? And how to implement PubSub and extending the architecture? These are lists of common challenges that developers are facing when they are building microservices. And we're going to help you answer these questions today. Let's start with containers, because more and more developers are adopting containers. We love containers because it simplifies development and provides flexibility. And this is the general landscape of container services on AWS. On orchestration layer, we have a couple of options, such as Amazon ECS for you who wants to simply deploy and operate your container application. And also Amazon EKS if Kubernetes is your preferred flavor. You also have a couple of options for computing resources. And if you want to have granular control, you can use Amazon EC2. But if you want to focus more on your products and less on the operations, you can use AWS Fargate, the serverless containers. And for today's session, we're going to focus on two AWS services, Amazon ECS and AWS Fargate. Amazon ECS is really excellent at the simplicity it provides. With Amazon ECS, it reduces the time it takes for you to build, deploy, or migrate your containerized application. And it comes with various best practices of running containers. As Amazon ECS is the container orchestrator, it still needs computing instances to host our applications. And that is where AWS Fargate plays a vital role in our architecture. With Fargate, it frees you from having to manage any of the underlying infrastructure. But the next question is how? How we can build microservices with Amazon ECS and AWS Fargate? And that's where AWS Copilot comes into the picture. AWS Copilot is a CLI tool that will greatly help you to get started with containers. Not only is it the best tool for you to get started, but also give you the flexibility to extend your system. AWS Copilot is a CLI tool and designed for both existing ECS users and new ECS users who want to focus on building application and its life cycle. And with Copilot, you can build or even extend your microservice architecture as it creates modern application deployments by default based on production-ready patterns that include best practices designed by AWS. So let's see AWS Copilot in action. In the first demo, we're going to deploy the application and deploy it into Amazon ECS and AWS Fargate. So just a quick overview on what kind of application that we are going to deploy today. The application that we are going to deploy is a simple application to return HTML based on the markdown text that we pass as input. So the application will convert the markdown text into HTML using HTTP post method. And also, as our application needs a database to log all requests, we're going to integrate our application with Amazon DynamoDB. We're going to use AWS Copilot to deploy our application. And at the end, we're going to have an application load balancer with a public address, which will be connected through AWS Fargate service, where our application runs inside the Amazon ECS cluster, and a DynamoDB table with record IAM role for our application. Wondering how all of this works? Let's jump into demo.
In this demo, I'd like to share you the capabilities of AWS Copilot to deploy your applications and how to integrate with Amazon DynamoDB as database. This is the source code of the application. The application itself is written in Python and using Flask framework. In this main application, I have a function called as save data. This function will save the request this application receives into a DynamoDB table. And if we scroll down, we can see that for the same endpoint, which is root, I have defined different processes for get and post method. For every request to get method is simply going to return OK. And this endpoint with get method is mainly used for health check by ALB. The other method, which is post, is going to process the markdown text and return the HTML response and log the request to DynamoDB. Okay, so now our code already integrates nicely with DynamoDB. I also have a Docker file that is going to be used to deploy the application. This Docker file uses Python 3 as the base image and is going to install the requirements, running on port 9090 and run the application. Okay, so that is our application. Now let's switch back to the terminal and initialize this application with AWS Copilot. I'm at the root folder of the application and I need to run Copilot init. Init command will ask us a couple of questions, such as the application name. Then it's going to ask us the type of the first workload that we want to deploy. As I'm going to deploy an API that needs public access, then I choose load balance web service. Then I will give this service a name. And you can see that Copilot is smart enough to gather all Docker files listed on the applications. And in this case, I want to deploy the markdown service. So let's choose that. And now let's wait. In this init process, it also asks if we want to deploy the application in a specific environment, in this case, test environment. I'm going to skip this part as we need to integrate the applications with database using Amazon DynamoDB. So you might be wondering, where is the specification file that instructs Copilot to do all of this? Once you have initialized your applications, services, or tasks, Copilot creates a manifest file which you can find in respective app folders. And let's open the file. This is the implementation of IAC, and you can actually configure this file manually. Let's say that you like to change the path, or even the health check path of the application. You can also configure the value of CPU, memory, to how many tasks that you want the service to run. And to apply the changes, all you need to do is to execute Copilot deploy. At this point, we only have one service configured. And if you want to add another service, you just need to run Copilot service init. Now, let's set up an environment called test. And we're going to use this environment to deploy the markdown service. To create an environment, you can just run Copilot env init, and it will guide you through a series of configurations that you like to have for your environment. Copilot will ask you the environment name, credential source, and the network configuration for the environment. I'm using the default configuration, and that is a new VPC, 2 public subnets, and 2 private subnets. And that's it. We just need to wait until it's finished. At this stage, I already have a test environment properly configured by AWS Copilot. Now we need to add a database. So let's run Copilot storage init. Once we run this command, it will ask us a couple of questions, like storage type. In this case, we choose DynamoDB. Then the resource name, partition key, and others. So let's finish this process. Okay, so it's done creating the manifest. And you can also see the environment variable for the DynamoDB table that we can use in our code to define the object for DynamoDB table name via the environment variable. So let's change the table name by using the value from environment variable. Okay, so now the application should connect to the DynamoDB properly. Next, manifest file. To find the manifest file, you can browse to the add-on folder. As mentioned, if you need to integrate your applications with other AWS services, you can create AWS CloudFormation template in this folder. Let's take a look into the manifest file. This is how manifest file looks like. It is a CloudFormation template, and in this case, it defines Amazon DynamoDB for our application. If we scroll down to the end of the file, you see there are 2 outputs, and one of them is the IAM role. This is important, and hope you don't miss this part, because this IAM output will help Copilot to inject into your application so it has sufficient permissions. Alright, at this stage, we don't need to change anything. So let's deploy this DynamoDB integration. To deploy the application, I just need to run Copilot service deploy and add the service name. This will take a while, so let's wait until it's finished. Alright, seems the deployment is finished and we have all required resources, from DynamoDB to the IAM role attached to our application. Now I want to check if the DynamoDB is created, so let's go to the console. This is my DynamoDB console, and if I filter by the name, I can see there's 1 DB created. Now if we run the API endpoint, if we execute the curl command to the API endpoint with post method and input text hello world from AWS Copilot in Markdown syntax, we will get the HTML format of the input, and it also logged the request into DynamoDB table. So let's go to the DynamoDB console to see if the last request is logged properly. And now you can see that our application now integrates nicely with DynamoDB, and we can see the last request is in the database. And that is how you initialize Copilot application, create an environment, deploy a service, and integrate your application with other AWS services using AWS Copilot.
Now, when it comes to building microservices, one of the best practices is to implement CI/CD as early as you can, simply because CI/CD will increase your development velocity. So in the next demo, we're going to build a release pipeline. Whenever we push our changes into our Git repository, it will automatically build the application and deploy to multiple environments in Amazon ECS and AWS Fargate. It's not hard as it seems. In fact, with Copilot, it's simple and straightforward. So let's jump into the next demo to implement CI/CD with AWS Copilot.
In this demo, we're going to create a release pipeline for multiple environments called test and prod using AWS Copilot. To create a release pipeline, all we need is to do 3 commands. First, Copilot pipeline init. The second step is you need to commit and push all changes to your Git repository. And the third step is to update the pipeline configuration by running Copilot pipeline update command. So let's do them one by one. Let's run Copilot pipeline init. This command will not create your pipeline yet, but it will create manifest file that will be used to create your pipeline. You can find those manifest files inside the Copilot directory. There are 2 new files generated by Copilot. They are build spec and pipeline YAML configs. Let's go through each of them. Build spec file contains the instruction for building and publishing your service. For most cases, you can leave the build spec file as it is. But for some cases, you might want to run additional command and you can add them to the build spec config. As for the pipeline file, this file contains instruction on how code pipeline needs to retrieve the source file, which environments you want the pipeline to deploy to. Let's commit and push the files. Then we can instruct Copilot to integrate this pipeline with Copilot Pipeline Update, which will let Copilot to integrate with AWS Code Pipeline and also AWS Code Build. And in this stage, if you're using an external Git provider like GitHub, Copilot needs to create the connection, and we need to update the pending connection as a way to approve it to make available for use. So let's wait. We can also check the end result of our pipeline in the Code Pipeline console. This is the visual representation of our pipeline. You can see that we have 3 steps here: source, build, and deploy. And all of these steps passed successfully, indicated by green label. Now we are going to add another environment which is called prod and set up the pipeline to deploy to the prod environment. To do that, we need to create the prod environment. We simply call Copilot env init again, and this time we will name it as prod. Alright, now we have the prod environment set up. Next, we need to open the pipeline YAML and add the prod stage. Now, to add the prod stage, we simply add a new line and name it as prod. That's it. Very simple, isn't it? This way, we instruct Copilot to create the pipeline and also for the prod environment. Now, one thing that you need to remember is Copilot will do deployment in the order of the stages that you have defined here. In this case, we have the test environment first to be deployed, and later on it will be deployed to prod. But in practice, we don't want to deploy automatically to the production environment. And with Copilot, we also can enable the manual approval step before the deployment. To do that, we need to go to the prod stage and add requires approval properties. This will instruct Copilot to pause and wait for approval before deploying to production. Now let's update the pipeline. And if we check the pipeline by running Copilot pipeline status, we can see that the deployment to test environments is finished. So let's go to the Code Pipeline console. When Code Pipeline finishes the deployment to test environment, the pipeline stops and not reach the prod environment yet. We now need to manually approve it to deploy to production. So let's click this button. And this feature is super useful in practice because most of the cases, we need to ensure that everything works fine. We need to do UAT first before it goes to production. We need to have somebody to review it first before it deploys to production environment. And this is the implementation of continuous delivery as we have a manual approval before it goes to production. And that is how you build pipeline with multiple environments with Copilot.
At this stage, you have a good understanding for the set of capabilities on how AWS Copilot can help to deploy services, integrate with database, as well as implementing CI/CD, all with a single tool using AWS Copilot. And the more you develop your applications with cloud computing, eventually you will have the need to integrate with fully managed services like scalable file system with Amazon EFS, or even creating a custom IAM role to access other services. So the next question is, how do we integrate our applications with other services? Fortunately, you can still do this with AWS Copilot. Copilot has the feature called add-ons that allows us to add additional AWS resources by leveraging CloudFormation templates. Now, you probably have a question. How can I get started easily defining the resources with AWS CloudFormation template? And this is a good transition for me to share with you another tool, and that is AWS CDK. The AWS Cloud Development Kit, or AWS CDK, is an open source software development framework to model and provision your cloud application resources using familiar programming languages. You can do this in different programming languages such as Python, JavaScript, TypeScript, Java, or C#. And with CDK, you will be much faster than using previous tools because there's no context switching as you work with your familiar programming language and concepts. And with AWS CDK, you can also generate CloudFormation template by running CDK synth command. Pretty awesome, isn't it? In the next demo, to demonstrate how to integrate AWS CDK and AWS Copilot by creating add-ons, we're going to build a new service called text, which need to evaluate the text input provided by the client and predict the language of the input, as well as extracting key elements found on the input. As you might guess it, this is a task of machine learning, and we're going to integrate the service with Amazon Comprehend. Amazon Comprehend is a natural language processing service which will make our task a lot easier as we don't need to build our own machine learning model and we can just call the API provided by Amazon Comprehend. But there's another thing that we need to do. As AWS is secure by default, we need to add permissions through IAM for our application to call Amazon Comprehend. And this is where CDK plays a role in our process. So let's jump into the demo to show you how to integrate between AWS CDK to create the IAM profile and AWS Copilot can be done.
In this demo, we're going to integrate our application with Amazon Comprehend. We're going to do that by adding a new service called tag service. This is the source code of the tag service. As you can see, this application receives the input from post method and getting the JSON payload. Then it tries to detect the dominant language provided by Amazon Comprehend API. If the text is in English, it proceeds by calling another API to extract entities in the text. Then we will return the results. Now, as mentioned, if we just proceed by deploying the application without setting up the IAM policy, we're going to get the permission issue. Simply put, because our application it doesn't have any required permissions to call Amazon Comprehend API. So in this case, I have deployed the service. And if we follow the logs by running the Copilot service logs with follow flag, we can see the latest log from the application. And if I open a new pane and run the curl command to simulate the request with the payload, we will see we have internal server error from the status code. Now, if we see the logs, we can see that there's definitely a permission issue. So what we need to do now is to add the permission. So let's open our CDK application. The goal of building the CDK application is to create a policy which has sufficient permissions for our tag service to call Amazon Comprehend APIs. I'm implementing a least privilege, so I just need to allow the policy to have specific actions. In this case, it's performing two API calls, detect dominant language and detect entities. Then, if you're creating add-ons template for Copilot, one of the most important steps is don't forget to output the ARN of the resources. In this case, is the manage policy ARN. Okay, so everything seems properly configured. Next thing that I need to do is to get the CloudFormation template generated by AWS CDK. To do this, I can run CDK synth command and piping the output to a specific file. Then we need to edit the file so it's compatible with AWS Copilot add-ons. First thing is that we need to find the parameter section and remove everything. The reason is because we are going to add Copilot add-ons parameters. And they are app, which is the application name, env, and this is the environment name, and the last one is the service name. Once we have made the edit, we can simply move this file into the add-ons folder within the Copilot. What I need to do now is to create the add-ons folder first, as it's not created by default. Then I move this file into the Copilot add-ons folder that we have just created. Then if we go to the Copilot service folder, this is how the tag service files looks like. Alright, we have done all the hard parts. Let's deploy the tag service. Okay, so now it's already been deployed. Let's check if the application is working as expected. First, we need to get the URL so we can test it out. We can do that by running Copilot service show. Now I'm going to send a curl request to the text service. The input text that I used was the sample text when you log in into Amazon Comprehend console. And if I run this command, you can see that now the application works. And that means we have now integrated the AWS CDK as a tool to create IAC and use the add-ons folder within Copilot. So we can create and integrate additional resources with AWS Copilot applications.
And microservices is not only about the infrastructure. The heart of microservices lies on how the services communicate to each other. In microservices, applications are decoupled into smaller, independent building blocks that are easier to develop, deploy, and maintain. One of the patterns that we can use to decouple our services is called pub/sub. Pub/sub, or also known as publish subscribe, is a form of asynchronous communication for service to service that provides instant event notification as we decouple our services. With AWS, you can easily implement pub/sub by integrating Amazon SNS and Amazon SQS. SNS is a fully managed pub/sub messaging service that lets you fan out messages to large numbers of recipients at one time using topics. And with Amazon SNS, you can easily subscribe Amazon SQS queue to Amazon SNS topic, allowing your services to process the message independently at scale. Let's jump into the next demo to see how we can decompose our application into independent processes by using pub/sub with integration of Amazon SNS and Amazon SQS using AWS Copilot.
First thing first, let's look at the code that I have. There are two folders in this root project folder, pub and sub. If we go to the Copilot folder, you see there are two folders created based on the service's name. Let's go to the pub first. This is the manifest file for the pub app. I define the type as load balance web service, and it means that we instruct Copilot to create application load balancer and target this application running on Amazon ECS and AWS Fargate. The image that I use is the Docker file that resides within the pub folder and running on port 9090. And this is the pub app. It needs to publish to Amazon SNS topic. And to do that, you can define the Amazon SNS in this line. With publish field, Copilot will create an SNS topic called as ping and set a resource policy on the topic. This will also allow Copilot services called sub, which is going to be our subscriber. Moving to the sub manifest file. Similar to the pub manifest, and the difference on the type is that it's a worker service and defines the subscribe fields to topic called ping, like what we have defined earlier and coming from pub service. We can also define the dead letter queue, and it tells SQS how many times to try redelivering failed message before sending it to the DL queue. And we can do more to row inspection from there. And from this manifest, Copilot will create a subscription between this worker service queue and the ping topic from the pub service. If you're deploying the SNS topics, it will create a variable called Copilot SNS topic ARNs and Copilot queue URI for us. Then we can use those environment variables into our application. To get more details for each service, we can use Copilot service command. Let's try to get details for pub first. We can see that we have environment variables called Copilot SNS topics. And if we do the same for the subservice, we will get the envar for SQS queue. You see that we have Copilot queue URI. Then same with the SNS topics, we can then use the envar and inject into our application. Now let's try it out. I'm going to split the terminal here. On the top side, I'll get the ALB IP address and make a curl request. And for the bottom side, I will follow the logs from subsurface to see if it got the messages that published by the pub. First, let's get the ALB address. The ALB DNS address is listed here. And let me do curl command. And on the bottom side, let's watch for the logs for the sub. And to get the logs from service, we can use Copilot service logs command. And the follow flag is pretty useful as it's going to show you all the logs from the running service. And you see that we have the message published by the pub app to Amazon SNS topic, and the sub app received the message from Amazon SKSQ.
And that demo wraps our session for today. If you'd like to learn more on how to develop containerized application with AWS Copilot, you can visit copilot.rocks, where I document all my learnings and solutions to work with AWS Copilot in form of tutorials and source code, including all demos that I have presented in this session. Also, if you want to start your learning journey with AWS training and certification, please scan the QR code provided on the screen. And one more thing, to improve the quality of upcoming events and to help you with more relevant content, please take the time to fill out the feedback form and please share your feedback. So that's all for today's session. Thank you so much for your time. Hopefully the content and demos presented in this session help you understand how to build microservices with best practices using AWS Copilot and AWS CDK. But more importantly, for you to enjoy more and having fun building applications with AWS. Also, if you have any questions, feel free to reach out to me on Twitter or LinkedIn. Once again, thank you so much. I'm Doni Prakoso, and happy building.